Good morning, Year Nines. I'm Mr. Vincent. Hope you're all well and staying safe. For today's lesson, we will be looking at how do we calculate kinetic energy. Please make sure you have a pen, a ruler, a calculator, and a few blank sheets of paper in readiness to do the practice questions as we go through the slides. If you haven't got them with you, please pause the video now and collect your equipment. Great, let's proceed. Please attempt these 5 questions on this remember slide now all on your own. Pause the video to attempt them. Let's go through the questions together. The first question says, write the equation for calculating gravitational potential energy. And the equation for calculating gravitational potential energy is E subscript P equals mass times the gravitational field strength times the height. You can write this equation in words or in symbol form like I have done. Just write E subscript P equals mgh. Both are correct. Now for the second question, I want to point out something to you. In the question, the two values that are given to us, the gravitational potential energy and the height, are not in the standard SI units. That means we need to convert this to joules. At the moment, the potential energy is 1,800 kilojoules. We need to multiply by 1,000 to get rid of the kilo. And similarly, the height is 12 kilometers. We need to multiply by 1,000 to get rid of the K so that it will be 12,000 meters. When we do this, we rearrange the equation to get the equation for mass, and mass equals 1,800,000 joules divided by 10 multiplied by 12,000 meters. Computing that in your with your calculator should have given you 15 kilograms. So the mass of the dog is 15 kilograms. The next question was to write the equation linking pressure, force, and area. We studied that in year 8. There was a review in the last lesson. So this equation is pressure equals force divided by area. You could have written P equals F forward slash A, or if you've written it in words, that is perfect as well. The next question was, what is the unit of force? The unit of force is the newtons, and the unit of energy is the joules after James Joule. You studied that a couple of weeks ago. Let's proceed with the lesson. As I said earlier, we're going to be looking at how do we calculate kinetic energy. This is another equation you will need to be able to recall, rearrange, and apply when you're doing your GCSE exams. We're going to be writing our answers in SI units, standard SI units. And finally, we're going to try and equate gravitational potential energy to a kinetic energy, because we know that energy cannot be created or destroyed. It can be transferred, usefully transferred, stored, or dissipated. And we're going to be using the law of conservation of energy to do number 4. Now, let's write down a formula for kinetic energy. Any object that is in motion has kinetic energy. So E subscript K equals half mass times the speed squared. There's a superscript there. The squared means V multiplied by V. V multiplied by itself. It's not V multiplied by 2. That is a common error a lot of students make. So in words, you can say kinetic energy equals 0.5. That is how we represent half as a decimal is 0.5. 0.5 multiplied by the mass multiplied by the speed squared. In symbol form, you can write E subscript K equals 0.5 or half multiplied by mv squared. Of course, we know the units of kinetic energy or energy in general is joules, mass in kilograms, speed in meters per second. Now let's take an example. The example says a cyclist with a mass of 80 kilograms cycles at a speed of 12 meters per second. Calculate the kinetic energy of the cyclist. The first thing we do, we write down our equation. EK equals half multiplied by the mass multiplied by the speed squared. We know from the equation, from the question, sorry, the mass is 80 kilograms and the speed is 12 meters per second. We substitute these values into our equation. We have EK equals 0.5. That's how we represent half as a decimal. Multiplied by 80, multiplied by 12, multiplied by 12. That's what 12 squares mean. You have 12 multiplied by 12. Compute that in your calculators. You have 5,760 joules. Here's a practice question for you to try out. It says, how much kinetic energy does a 30-kilogram dog have when it runs at 4 meters per second? Pause the video now and try this question on your own. Right. Let's see if you had the question correct. Let's check, go through together. Now, when you look at the question, the first thing you do, you write down your formula. K equals half mv squared. Now, in the question, the words mass and speed were not used. However, the values given to us in the question has units. So it says 30 kilograms. We know when they say 30 kilograms, we're talking about the mass in this case. And 4 meters per second, we know that's the speed. So even though the word mass and speed were not used in the question, we should be able to find them from the question, get the values from the question based on their units. And in doing so, we know the mass of the dog is 30 kilograms and the speed is 4 meters per second. Substitute these into the formula. Don't forget your superscript 2, say 4 squared, speed squared. Compute these in your calculators. You should have 40 joules. Now try these questions out. Please pause the video and attempt them on your own. Right, let me display the answers so you can mark. These are the answers to the questions. On the previous slide, if you have 3 out of 5, 4 out of 5, 5 out of 5, congratulations, you can proceed. If you had 2 out of 5 or 1 out of 5 or even didn't get any correct, I suggest you go through this first half of the slide until you understand this concept before proceeding. Now, we want to rearrange the equation such that mass is going to be made the subject of the formula. So write the equation down. We write the symbol form. Now I've rewritten the symbol form as E subscript K equals mv squared over 2. It's the same as saying half mv squared. The 2 is still in the denominator, and this is the same as writing it as E subscript K equals half mv squared. Now I'm going to use this form to rearrange the equation. The first thing I want to do, we want to make mass the subject of the formula. We have a v squared on the right hand side by the m. We have a 2 in the denominator. We need to get rid of the v squared and the 2 so that m is alone on one side. That's when m would have been made the subject of the formula. First, I'll try to get rid of the 2. So because I have a 2 in the denominator, I have to multiply both sides by 2 to cancel the 2's out. Right, so you notice on my right hand side, I have a 2 in the numerator and a 2 in the denominator. These 2's will cancel out and I'll be left with 2 multiplied by E equals mv squared. Again, I've still got a v squared by the m and I need to get rid of this v squared because I need m alone on one side of this equation. So I divide both sides by v squared, and that means on the right hand side of the equation, I have a v squared in the numerator and a v squared in the denominator. The v squares will cancel out. That leaves me with 2 multiplied by a over v squared equals m. All we need to do, like in the previous slides, is to write m such that m is on the left hand side of the equation. So we'll have m equal 2e over v squared. That's when m is the subject of the formula. Let's take an example. It says a book falls off a shelf. Just before impact, the book had 2.25 joules of kinetic energy. The speed of the book just before impact was 3 meters per second. Calculate the mass of the book. From a question, we can see that we have kinetic energy is as 2.25 joules and the speed as 3 meters per second. So we write a formula down: mass equals 2 ek over speed squared. We substitute our values for ek and speed into the equation and we get that. 2 multiplied by 2.25 divided by 3 squared. Compute that using our calculators. We should have the mass of the book as 0.5 kilograms. Please don't forget your units. Here are 3 questions for you to try out. Pause the video now and attempt these questions. Good. Let's look at the answers to these questions. Note for question 3 that the mass you would have calculated would have been the total mass of the child and the bike. And then the question provides us with the mass of the child as 30 kilograms. So then we have to subtract 30 kilograms from the 68 kilograms to get 38 kilograms, which is the mass of the bike. The child and the bike form one system. That's why you have the total mass as 68. Subtract mass of the child, then we get the mass of the bike as 38 kilograms. Hope you had all of them correct. If you didn't, please go through the section again and reinforce your knowledge. The next thing we would like to do is to make V the subject of the formula. We write down as equations again, and we're going to use EK equals mv squared over 2 to make V the subject of the formula. Of course, we have m next to V and we have 2 at the denominator underneath V. So we need to get rid of the 2. We multiply both sides by 2. Cancel the 2's out. And we're left with 2 times E equals mv squared. Still, I've got an m next to V, which I don't need on that side. I need to get rid of the m. Therefore, I divide both sides by m. And then you'll find out on your right-hand side, you have an m in the numerator and an m in the denominator. The m's will cancel out. So we are left with 2 times ek over m equals v squared. Right, I want speed v and not v squared. So again, I have to take the square root. The fifth step is to take the square root of the other side to get rid of the square. So we're left with square root of 2ek divided by m equals v. Again, because of space, I cannot write the final step, which should be v on the left-hand side. Rewrite the whole expression such that v is on the left, which will be equal to the square root of 2ek, the kinetic energy, divided by the mass. Now, let's take an example. It says a moving car has 14,000 joules of kinetic energy. The car has a mass of 900 kilograms. Calculate the speed of the car. We just quote our equation from the previous slide. Now it's written in the form wherein V is on the left-hand side. So we know from the question our kinetic energy is 14,000 joules. Our mass is 900 kilograms. Substituting these two values into our equation, this is what it should look like. You can represent this. If you have a scientific calculator, you can do this exactly as it displays on the screen using the square root button and the fraction button, and then you can enter your values. If you're using an adding machine, then you have to compute this in bits and pieces and then at the end you take the square root. Get an answer of V speed equals 5.58 meters per second. Don't forget your units. Here is a practice question for you to try out. Please pause the video at this point and go through this question. Now let's go through the question together. It says calculate the speed of a bus traveling through town with a mass of 5,040 kilograms and a kinetic energy of 493,000 900 joules. We first of all write down a speed equation. Speed equals the square root of 2ek over m. In an exam, you'll work from the first main equation, ek equals half mv squared. Rearrange the equation to get up to this point. Because of space, I'm quoting the equation directly from the previous slides. Substitute a value for ek, we know is 493,900 joules, and the mass is 5,040 kilograms. Substitute into an equation, this is what it should look like. Computing them with a calculator, your answer should have been 14 meters per second. Don't forget your units, please. Right, here are 4 questions for you to try out. Pause the video now and attempt these. Okay, let's look at the answers. Please mark, and if you scored 2 out of 4, 3 out of 4, 4 out of 4, congratulations, you can proceed. If you scored anything less than 2, you scored 1 out of 4, even 0, you didn't get any right, please, I suggest you go through the section again until you understand the concept. Okay, we now move on to the 4th point for today's lesson, which is the loss in gravitational potential energy equals the gain in kinetic energy. We want to use the law of conservation of energy to help us understand this concept. The law of conservation of energy states that energy cannot be created or destroyed, but it is transferred usefully, stored, or dissipated. Now, most rides in a theme park make use of this concept of gravitational potential energy being converted to kinetic energy. So, in this case, the cars are taken up to the highest point on the ride. That means at that highest point, at this point, gravitational potential energy is maximum, and then suddenly going down the descent, the speed increases, and gravitational potential energy is converted to kinetic energy. Just before the car reaches the water level, the gravitational potential energy would have been converted to kinetic energy. We are assuming in this case that there is no air resistance. So if there is no air resistance, all of the gravitational potential energy will be converted into kinetic energy. Okay, same with this pendulum boat. At this maximum point, there is no kinetic energy, but there is a maximum gravitational potential energy. As the boat swings back, at this low point, there's a maximum kinetic energy, but minimum gravitational potential energy. Right. How does this apply to us in the situation? Let's take an example. It says a ball with a mass of 2 kilograms is dropped from a height of 20 meters, assuming all of the GPE transfers to kinetic energy. Calculate the speed of the ball as it hits the ground, G equals 10 newtons per kilogram. At a height of 20 meters, the ball has maximum gravitational potential energy. So, we first of all write a gravitational potential energy down, and from a question, we have 2 kilograms as the mass, 20 meters as the height, G as 10. Compute that, we have 400 joules. Now, this 400 joules is the total energy, gravitational potential energy the ball had when it was at a height of 20 meters. As the ball begins to fall down just before it hits the ground, all of this 400 joules is converted to kinetic energy. So we equate 400 joules to half mv squared. The mass of the ball is the same, so we substitute the 2 kilograms for the mass in the equation, and then we're asked to find v squared, the speed. Rearranging our equation, which we've done before, will lead us to v squared equals the square root of 2 multiplied by 400 divided by 2, which is the mass, and that should give us 20 meters per second. Don't forget your units. Here is a question for you to practice. Please pause the video and practice this question. Good. Let's go through the question together. It says a diver stands on a board 5 meters above water. The mass of the diver is 60 kilograms. Calculate the diver's speed when he hits the water. Give your answer to two significant figures. G equals 10 Newton per kilogram. Again, at the point 5 meters above water, the diver has his maximum gravitational potential energy, which can be calculated using the equation EP equals mgh. EP, the mass is 60 kilograms, G is 10, height h is 5 meters. So the moment the diver leaves the diving board, jumps off the diving board, his gravitational potential energy starts decreasing and converts itself to kinetic energy, which increases. And just before the diver hits the water, all of his gravitational potential energy would have been converted to kinetic energy. Hence, the 3000 joule is now equated to half mv squared. We are assuming there is no air resistance. Now, 3000 joules equals half m is 60 kilograms v squared. Rearrange the equation to make v squared the subject of the formula. Take the square root and we get v equals 10 meters per second. Right, here are 4 questions for you to practice using the same idea. Pause the video now and go through these questions. Okay, great. Let's see. These are our answers. Please mark your answers now. If you had 2 and above, that means 2 out of 4, 3 out of 4, 4 out of 4, congratulations, you can proceed and do the quiz. If you had less than 2, 1, or you didn't get any correct, my suggestion is you go through the slides again to improve your understanding. So, if you understand, move on to completing the quiz. Otherwise, please do the video again until you're confident you understand this topic. Thank you.